Welcome everybody. This is round 2 for beginning Linux. We are going to be just going over the basic commands, their DOS equivalents, some basic ideas. Ideally, I'd like to actually have 2 projectors, so we're going to be switching back and forth between 2 screens. If you have any questions or examples that need to be shown. If you have any questions on commands during the session, just shout them out, and I'll see what we can do about getting them answered. If you have Linux installed on your laptop right now or on your computer right now, you can drop down to a command console. If you don't know how to do that, that can be done by simply hitting Control-Alt-F1, and that'll bring you directly into a command console where you can log in, and you can play around with them as we go. We won't be doing anything that's going to screw up your system this lesson. Again, if you have any questions, let me know. Several people here I don't think were here last time. I don't know if you saw the first session where we just kind of went over file structure, basic Linux structure, kernel, all that stuff. This session is available online. I don't know about the video, but are we doing a video?
Yeah, I haven't published it yet. I've still been kind of playing with video editing, so I haven't.
The presentation currently is available on the website. It's at least available in the Open Office format, but I think we're going to put it up in Macromedia as well so everybody can see it. And this is session 2. We're just going to be going over basic commands to get you familiar with the console.
What's the website?
Fosug.org. FOSUG.org. www.fosug.org. Most of the commands that we're going to be using here are going to require a bash compatible shell. Pretty much every variant of Linux and most variants of Unix are going to be extremely similar. The commands are going to be extremely similar. They try to keep them pretty much consistent. We're going to go over just the basic top 4, kind of the most important concepts you'll need to understand to get into scripting and to get into the more advanced information, and then we'll be going over standard commands, copying files, moving files, listing files, stuff like that. First thing, right off the bat, is if you're a new Linux user, what is the single most important command that you're going to learn? And no matter if you talk to anybody that is into Linux, they're going to immediately tell you to read the manual. The most common, if it would actually change slide, which it doesn't seem to want to, is the man command. Anytime you get information, use the man command, because there are a lot of people out there that may not give you legitimate information and may have you do something that's not quite smart to do. Man is used for reading manual pages or instructions. Example would simply just be typing man and then the command you're interested in finding out information on. These 2 examples, ls and ipconfig. Here's an example. I don't know if anybody can see it. I certainly can. But we have man space grep. And it's going to tell us what grep is. How to use it. Let's go ahead and switch here and try this. It might look a little better. There we go. Gives you various variations on the name, aliases, and tells you what it does. Grep is something we will use a lot when we get into scripting, or just searching for files. Grep is your god.
Drew, what are the different variations with the names up there? It's talking about grep, egrep, fgrep.
The different variations were basically, grep is just for searching for information, and there are some other variants that work a little bit differently for other situations, but they're based on the same idea. If you go down here, there's actually lots of documentation here. If you go ahead and do a same thing, it's just an alias or a slight different version. And I cut this down a little bit because Grep's got a huge manual. Basically, with the man, this is what I want you guys to do. Anytime you get a command or somebody tells you to do something, if you're confused about a command, type man, it'll give you the answers. Usually the first paragraph will get you what you want. If you forget something, man's going to have it. If you talk to anybody on IRC, please do a man on anything that they tell you to do. There's a lot of people out there that consider themselves a lot higher than you and are going to have you type in commands to, quote, fix a problem, and you're going to end up deleting your system or doing something really bad. Screen is probably one of the most useful utilities that you can use outside of a command, or actually when connected remotely to a system. I don't know if we're going to be starting this, but we're going to try to get some shell accounts set up where people can get accounts on. They can start playing around with scripting and coding without actually having to set up the systems on their own. They can log in remotely, which will start probably not next month, but the month after that. Screen basically allows you to attach to a process, run the process, disconnect from it, and it continues to remain running. If you were running remotely and you disconnect your normal connection, you've just lost whatever you're working on. Screen's really nice because you can resume later. There are a lot of options for screen. These are going to be the standard ones. Screen is just launches a new screen session. Screen X or -X will reattach you to a session. You can also use -R to reattach. Screen -X will also allow multiple people to attach to the same session. So when we start getting into scripting, I'll actually have everybody attached to the same session, and we can all work in a similar session.
Which distribution is this based on?
This here, these are pretty much across all distributions. You're going to find these utilities and commands. The ones we're probably going to be using is most likely Fedora. I personally use Gen 2, but it's going to be exactly the same.
Which core? One?
It doesn't matter.
Doesn't matter?
Yeah.
I heard there are some compatibility issues between like core 2 and core 3.
There shouldn't be any compatibility issues. There might be some problems with the way people have packaged certain programs. If they did not package them properly, then there's going to be some dependency issues. But that has to do with how they package the software. Here's an example. These really aren't shown up too well. I'll have to move the font up for the next one. This one will also be available online so you can see. But basically what we have here is just a console screen. We run screen. Once we run screen, it's going to basically give us a command prompt just like we had. The only thing is now this is protected. It's kind of running in the background, and you're just viewing it. If you disconnect or close the window, everything that you do in here is going to continue running until you manually go in and kill the process, or you log back in and you exit out. We just load something up like top. Top is a way to view your current processes that are running on the system. This is basically what top's going to look like. It's going to show you how many tasks are running, or total tasks running, how many are sleeping, meaning they're running but they're not actually doing anything. How many are stopped, how many are zombie. This is your equivalent of a crash program. You generally don't see too many of them. CPUs, utilization for different aspects of memory, system load, or hard drive access. And then here's a listing of everything you have. This list actually goes on quite a bit. But it's just truncated so we don't have to show these massive screens. You wouldn't really do this particular example because top uses a lot of system resources and there's no reason to keep it running in the background. But we're going to do it anyway. We're just going to lose our connection. Our dial-up modem hung up or something. If we were editing a file, we would have just lost that file if we were not in a screen session. Well, we just reconnect back in and we issue the command screen-X. And this will reattach us to a session that's already running. If there's more than one running session, it's going to give you a listing of the sessions that are running and you can attach to a specific one. And we connect back in exactly the way we were. no change. Pipes. Pipes are not really a command, they're more of a process. But once we get into scripting, they're going to be one of the most used things we do. Basically, a pipe allows us to take the output from one program and pipe it into a second program's input. This could be a display output from a file that's giving you information. It could be a web page that you have the source code viewed. It could be a sound program, and you want to have the sound output go directly to somewhere else. Basically, because of the way Linux works, every single aspect of Linux, whether it be a device, a file, a piece of hardware, everything is treated as a file with very similar input and output. So you can redirect and change your input and output from a program to pretty much anything. Very, very powerful. Simple example here would be ls. This is just listing files. We use our pipe command, which looks a little funny here. It looks a little different in the console. To grep. Grep is used for searching text. So we're going to search through, basically we're going to do a directory listing, and we're going to tell it, pipe this information into grep. And grep is currently going to just show us anything with the word fosug in it. So any file with the word fosug will be displayed as your output. Because the output from ls here, we never see. It is immediately pumped, it's immediately piped into this program. This program now handles the output. Another example would be to just view a file. If you wanted to view a file, say cow.txt is an extremely long file. If I did cat cow.txt, this is going to be displaying the file, but it's just going to scroll across the screen. Less is a program that grabs your screen size and will pause the page after a single page. It's very similar to more, but less is actually more than more. It's confusing. So it tells us, take this information, send it, pipe it into this program, and let this program handle the output. This is also a bad example because there are other ways to do it, but that just shows you how the pipes work. Actually, I have an example. It looks like the cat cow.txt. We go ahead and do that just by itself, and it flies through. You don't see anything. This was actually a really long file, and we only see the tailing end of it. We go ahead and we change it again, and we use cat cow.txt, pipe it to more, and actually what it's done is it's drawn the first half, and it's paused the page, and it just continues for several pages of cows. Grep. Grep is a very powerful tool. When we get into scripting, which will probably be in about 4 lessons, grep will be used for virtually every aspect of scripting. Pulling information from configuration files, getting information off the internet, parsing that information. You can do a lot with grep. Basically what grep allows us to do is search for text or variables within a file or IO stream. It's extremely powerful but very simple. Basically what we do, here's another example, displaying a file, pumping the output to the grep, and searching for a specific text phrase. This can be used for searching for variables or just plain text. If you have a huge file and you're searching for something specifics, you can have it display just the specifics of the file you're looking for. Grep is very powerful. Right now this would just return us a single line that has the word ASCII in it. We can actually tell it to display a certain number of lines before that, a certain number of lines after that. We can have it display everything after that. We can format text extremely quickly using grep. Wonderful program. I guess here's another example. We are viewing the cow.txt, and we're grepping for the word moo. The -I means case insensitive. If I did not put the -I, it's only going to look for move, lowercase. This will look for any case variations of that. And as you saw, there's a whole lot of actual cows in there. Well, now it doesn't really make sense because we just see partial lines. It's given us 2 lines that actually have the phrase move in there, right here and right here. If these had been configuration files and we were looking for specifics, like maybe an IP address stored in a configuration file, we'd be able to search for that and then utilize it in a script. dmessage, basically this is system. This will give you error messages and system messages that come directly from the kernel. If you're plugging in USB devices, unplugging USB devices, mounting drives, if there's a drive that's got a failure, and any information that needs to be known is going to be sent to basically your system log. Most systems, depending on the variation, will sometimes have, I don't know if I do, yeah, I have mine turned off. You'll actually have a console which is always displaying your system messages. I believe Red Hat, Mandrake, and Fedora automatically have this. To access it, you would just hit Control-Alt F10, or sorry, F11 or F12, and it'll basically tell you everything that's going on in the background. If you don't have that, you can call it up at any time. Simply running the command dmessage. And this is a very long file. It gives you everything from boot time on up. We'll actually just go ahead and pipe this out to less. We're taking the output of dmessage, piping it into the program less. So we can start viewing everything that our kernel is doing. Most of this stuff you don't need to know about, at least not yet. A lot of it is information you'll never use. But this does tell us everything as the system's starting out. CPU types, speed, everything. But as we get to the end, we'll start getting to some more information. The last devices that fired up, I just brought up my Ethernet card before this. It tells us everything that's going on. Give an example here. I'll just unplug my USB mouse here, and the system is going to respond, and we'll run dmessage again. And it just tells me at the end here, USB disconnect, address number 3. My mouse is now no longer plugged in. Go ahead and plug my mouse back in, and the system, give it a second here. Come on.
It's usually immediate.
It is, but I have a funky mouse. I have a broken mouse. I broke my mouse.
Bad example.
Bad example. Do as I say, not as I do.
You want a mouse?
There it is. As soon as I plug my mouse in, it's now just telling me new low-speed US device is using address 4. Each time each time you plug and unplug it, it's going to give it a new address until it hits the end, so they time out the addresses. Gives the information, and at this point, it's already loading the driver, which is set to automatically load, so I don't have to worry about that. If you were debugging your hardware, this would be very, very useful because you'd be able to look up information about devices that got attached and unattached without having to kind of play around with it. Shake up. I think I had same examples we can grab for certain things. Just do a standard connection here, but if we wanted to look for something specific, for instance, PCIs, message. We're going to pipe this into grep, change the output, and send it over to the grep program, and we're going to do a case-insensitive search for PCI, assuming I can type correctly. And now this just shows me things that have to do with PCI. It's not going to give me that whole long list. If you're searching for something specifically, it speeds things up drastically. Now these are just going to be some basic commands that you're going to see pretty much across the board. These right here, be careful because OpenOffice is having a tendency to try to correct my spelling errors and capitalize things that shouldn't be capitalized. Linux is case insensitive, and this should be lowercase. I should go back and change that. Basically, this just lists the directory contents. People that are familiar with DOS, I'm going to have the DOS equivalent because a lot of people, when they see Linux console, they think DOS. In reality, they're not similar in any respect except for the fact that it's white text on a black background. But there are DOS equivalents for a lot of these applications. LS is going to be very simple. Do this. Okay. I created a user called Fosug on here. Simply, if we want to list our files, we're just going to run ls. Again, I got to learn how to type. It just shows us everything that's currently in this file. 3 directories, 1 file. These are fake directories, of course. But as with any command, we can type it, just like everything we've been doing. Search for text files. And it's going to display only the text files. Very powerful. There are a lot of slash commands that we can use, or that allow us to add extra things, to have it display, groups, have it display in a human readable format. Some of these files, when you view it, Linux has a tendency to want to just give you information in actual bytes. A lot of people, if you have large files, we don't have any clue how to mentally make the changes, how big a file is in bytes. The human readable flag is going to give us something. Just going to change. The files are too small. It's going to start giving them to us in stuff we're used to. K. If I had larger files in here, you can see megabytes. Gigabytes would just be named gigabytes. Change directory. Change a working directory. DOS equivalent. Exact same command, CD. We can change to an individual directory that we know exists. We can change to, using a tilde, it immediately changes us to our own directory. If we have, for instance, my directory would be Doodle. So if I hit CD space tilde, it's immediately going to send me to my home directory if I've gotten out of my directory. So I'm in ECK right now. Tells me the directory I'm in. But if I wanted to go to my home directory, I just run the tilde command. I don't have a tilde key.
Can you just go to your home directory with CD and enter?
Some versions, yes, but I don't believe this one will do that. Actually, this one does do that. Not all versions of Bash or not all versions of shells will do that, but yeah. Copy, something you'll probably be doing quite a bit. Copy is very simple. The command is simply cp. DOS equivalent is going to be copy. The layout is going to be cp, our source file or directory, our destination, and any switches that we want to have. I should have switches there. Yeah. Example would be if we wanted to copy moo.txt onto my flashcard. Very simple. I would just run cp space the directory and file space and then the destination. I don't have to put the file name. If I put the file name, it will change the file name. If I put moo2.txt, it will copy the file, but it's going to be renamed. It works exactly the way the DOS version does. There are a lot of commands that will allow us to recursively copy. something that DOS did not have the capability of doing. There is a second program available for DOS called Xcopy, which will allow you to recursively copy. But if I wanted to copy home total and every other file in it, I could just do cp home, home total space, the destination space, dash, capital R, which is recursive. It'll copy all files and directories from that point on to the destination.
So then CP is more like you said, like Xcopy, where you have a lot more functionality.
CP is a lot more like Xcopy, yeah. It does have a lot more functionality. Do an example here. CP home. So we're going to copy everything in this directory to, yeah. Again, I got to learn how to type. See here, we'll do this. I think I have a flash directory. We'll just do this. We'll copy it to the floppy. And we'll do a recursive. Recursively go into the directories and copy those as well. And I always like throwing the V, because if you don't throw in the V, it's going to do it, but it's not going to show you anything. It's just going to be done. The V will actually show you the progress as it goes. Uh-oh. Well, I don't have permission to do that. Let me go into this real quick. Okay, we'll cheat. We'll change that. We'll pretend that this is a floppy. We'll just pretend that that subdirectory is a floppy, which this might actually give a weird result because we're recursively copying into a directory that's within. But it went ahead, copied all the directories, all the files. It's telling us here, this one can't be copied because I just did a recursive directory of the directory floppy into the directory floppy. So it skips this one and continues copying the rest. Normal home directories are going to have a lot more files, obviously, but these are just for examples. Move. MV is what you would use to move or rename a file. Linux does not have a rename command that's separate. If you want to rename a file, you simply move it. Same exact layout as you would have with CP, same switches in fact. MV, source file, destination file. This would rename the file. This would change my moo.txt to cow.txt, leave it in the same directory. Again, if I wanted to move this file onto my flash drive, I would do the exact same thing. The recursive, adding the -R, works exactly the same way. If I wanted to move an entire directory from one directory to another, I would do it exactly as I would. MV has some little interesting quirks maybe that you should know about. Although in all new versions they have been taken care of, but you should still be aware of them. Again, Linux does not have a rename command. You use the move command for exactly the same thing. Older versions of move can actually delete a file if you don't have a destination set. If I just typed mv moo.txt and pressed enter, it has just moved that file into the trash can, into nothingness. It cannot be recovered. It's gone. This here, the new versions will not actually do that.
It won't even go into like the Boston South folder or anything?
Generally not, because it's pretty much gone. Basically it sends it to the standard output, and if there's nothing receiving the standard output, it's basically lost. If the destination is a non-block device, you can also lose the file too. For instance, if you want your computer to talk to you, you can actually copy a file. If you had a text file with a bunch of text on it and you wanted your computer to speak it, you can actually copy that, CT, that file into dev/speech. And then your computer, if it's set up with the speech daemon, will actually speak that file. However, it's technically not a block device, and if you move that file in there, it will speak that file, but at that point that file is now gone. It's been successfully moved into that, so it's going to remove the original. You do have to be careful with stuff like that. Obviously, moving anything into dev null, which is basically the black hole of the system, everything that goes in there disappears permanently. If you move something in there, it's the same as deleting it. You know what? I did not put the delete in here. Delete is going to be, actually maybe I did. I did. Make directory, the DOS equivalent, depending on which version, is either going to be just plain MD or MDIR, which allows you to make a directory or folders. For instance, I want to make the directory Naughty Cows. I would just create the directory mkdir and then the directory name. We can put an entire path in there if necessary. RM. This is the equivalent of DOS or delete. Also, this is the equivalent of erase. This allows you to remove files or directories with some exceptions, which I'll go over in the next slide. RM, mo.txt, is just going to erase that particular file. Also, we can go into an individual directory and recursively delete everything in this directory on board. Any subdirectories and any files that are in it. Here's the text. RM is, you cannot use it to remove directories unless you specifically are removing directories recursively. If there was an empty directory, for instance, Naughty Cows, and I typed RM space Naughty Cows, the directory is not going to be erased. We would actually use RMDIR for this, which we'll get to in a second. If you are recursively deleting, it automatically does remove the files, the directories along with the files. Also, another thing to be careful with, if RM does not ask you, are you sure? For instance, in DOS, you did a delete star.star, :/, basically delete everything on your system. You press enter, DOS is going to say, are you sure? Unix does not ask. The only time it may ask you if it's the system, if the file is read protect only. So you will see there are a lot of idiots on IRC. When you log on and ask for help, they'll tell you, oh, use this command, and they'll give you a string of characters to put with it that will essentially erase your root file system. And you press enter, you've just nuked your system because it does not ask you, are you sure? Linux very rarely asks if you are sure. It assumes you know what you're doing. RMDIR is exact opposite as make directory. It removes the directory. The requirement that is that the directory does have to be empty. It will not recursively delete files and directories. It will only delete directories. And they do have to be empty. So you either have to manually delete the files or just recursively delete the files and the directory. RD and RDIR would be your DOS equivalents. CAT. CAT is the DOS equivalent of type or view. It allows you to view the output of a device or file. Cat meow.txt is simply going to display the contents of that file. We can redirect this. We're going to redirecting a lot more in the next ones, but we can throw the information from this screen and redirect it to somewhere else. Very similar to a pipe. Actually, almost exactly like a pipe, but used for usually devices. And we can send the output of that file to print. Clear is very simple. Same as DOS with CLS. We're going to clear the screen. Nothing special about that. DF, very similar to DOS's check disk. There's also new check disk. Check disk now just tells you how much information is being used, how many is in bad blocks, stuff like that, or how much information is on the drive. It doesn't actually check your drive anymore. Scan disk is what uses that. This here tells you how much how much information is free on your drive. DF, actually we'll do this real quick. It tells us how much is free. Again, these are the devices in my system. I have HDA1, which is my root file system. Then I have my home file system. And you get these lovely blocks that nobody knows how to read. It actually is really simple, but if you want a quick answer, you don't want to do math. We just throw the -H on there, and it gives us to it in human readable format. It's telling me I've got 5.2 gigs free on this drive, 13 gigs free on that drive. Hey, Cody. Hey. Disk usage, very useful. It lets you know, gives you an estimate, which is very, very exact actually, of how much file space is being used in a particular file or directory. A lot of / commands that we can use with this. If I just do disk usage, it's going to go through my system and tell me how much space is available in every subdirectory, or how much is being used. This is an empty directory. It's completely pointless. But we'll do something like this. Go to a subdirectory that does have a lot of files. On your whole system, it's going to tell you how big every directory and every file in that directory is taking up. Not very practical, but we can use it for gathering information when combined with a lot of / commands and grepping the output out. Very useful in scripts. PS reports the current processes. This is basically very similar to top. It does tell you what's running under a particular user. It gives us a report of current running processes. Example would be, actually we'll do this. Oh, the DOS equivalent. DOS doesn't have this because of its lack of multitasking capabilities. But here's a listing of everything that is currently running under my username, total. And it's a whole long list of items. It's giving us, these are their system ID tags, their PIDs, the process of identification, the actual program, how long they've been running. It's a big long list. If you're doing something real quick, you might be able to run it, get an idea of what's going on. I personally prefer using top. It's very similar. It gives you a listing of your processes. But it gives it to you in a format that is a lot easier to manage. It tells us who the user is, the nice level. This tells you how much system priority it's going to get. It also continues to update it, as you'll notice. CPU, memory utilization, time, and the actual command. We can go in here and have it just show me, okay, show me everything under my username. And now it's just going to show me what my username is using. And we can scroll down. These are every single aspect that's running in the system under my username. Right off the bat, you see my screensaver. This is the presentation software that's running. Nautilus is the file viewing and management utilities for GNOME, and quite a few other things that are running. And if we do all users, we'll see everything that's running in the system, all the background stuff. If you think a program has crashed, you can actually use, we'll go back to the top here for a second. If you're running something that you're pretty sure has crashed, we can actually kill a process from within here. If I wanted to kill something that would be safe to kill here. I'll go ahead and kill my screensaver. My screensaver right here, which is running the screensaver, waiting for the system to become bored basically to start displaying the screensaver. It has the process identification here is 72, or the PID is 7235. I can actually kill that. Actually, I probably can't kill that because I'm not root, but we can try. Go ahead and kill it. Yeah, it's saying I'm not allowed to do that because that process is owned by a user that's logged in. That's not the user I'm logged into now. So I can't go into here. Even though it does show me everything that's running on the system, I can't go in and start changing other users' processes. That would be very bad, especially when you're running a massive multi-user system. You're running your word processor program, writing your emails out, and I ticked off at you, so I go ahead and kill it. Not nice. Of course, I have root, so I can kill anybody. Who am I? If you're running a multi-user system, which we'll be getting, at least I'm going to try to get some shells set up so people can log in and play around. Who am I simply tells you who you are in the system. It's telling you I'm currently user FOSUG. When you're dealing with a lot of users or a lot of systems simultaneously, you can get confused. It's a nice command. Who am I again? A lot of them will also tell you right here what your user is. Control Z, this is something when you get into, on a local system, you're not going to use this a whole lot because you'll just simply open up another window and run it. But if you're running in a if you're running remotely, this is very nice. We can run a process, and Control Z pauses and halts the process. For instance, we'll just do a quick little program here. This is just a DOS screensaver, or a console screensaver. What I can do is I can actually, by hitting Control Z, stop this process. I have not killed this process. Basically, it's paused the process where it's held and put it to the side. Now I can do whatever I need to do right now. Find out what I'm doing, find the process, quit the process, and I can go back to my jobs and hit FG, which would bring that job back into the foreground and resume it. If I disconnect though, completely from the system, these will be lost. They're not like Screen, where you can resume it later. Or, although this is a really bad thing to do for this particular application, I can send this to the background, which now the program is running in the background. All it is a screensaver, so it's just wasting resources. But, for instance, if I was copying a whole lot of files, just massive amounts of directories, I can say, copy the files, pause that, send that process to the background, and continue my work. And it's going to continue working in the background without pausing. Unfortunately, we now are just going to kill this process. So these are all the files that are currently running under the user FOSUG. We're going to kill this one right here. C matrix 252. Are you sure? Yes, I'm sure. And why isn't it going away? Did I type that right? I may not have. Oh well. Let's see what else.
So if you move something else to the background, how do you get back to it?
There, I've never actually had a reason to do that. I believe you can do that with the jobs command, and you can bring it back into the foreground. Have you worked with that, done that, Steve? Move it.
Well, jobs will just give you like the process ID and job number, and then things like FG, and then you know which job number it is.
Oh yeah.
Things like
Okay, well, I just killed the job. But
No, I've never used jobs before. I usually just do PS hyphen AHF and then grep for the command string and then kill the process with the kill 15 or 9.
Oh well. Any questions on any commands or how you would go about doing something?
Yeah, but question. My name is Vince, by the way. On the copy command, I was reading on the forum where you wouldn't use copy for backups. You would tar the files and then back them up.
Yes.
But never gave me an explanation. I never found an explanation.
The reason for that is, unlike Windows files, DOS files, they're just a file. They don't have ownership associated with them, and they don't have attributes associated with them. The way Windows handles how a job is, or what type of file is by its attributes. Who owns it, whether it's executable, whether it's a data file, writable, readable, and who's allowed to write it. The attributes that can be put on a file, there's a whole lot more attributes versus what Windows is capable of. Windows is capable of 4. Is it writable? Is it read-only? Is it a system file? Is it a hidden file? And is it archivable? Those are the only 4 you have. Linux has a lot more options. And when you copy that, especially when you copy it across a file system, you lose all that information. You would lose the owners, who owns the file, a lot of its attributes, so you would not use copy, unless it's going to the exact same file system. But still, better idea is to tar it up, because you keep your directory structure, you keep your attributes, and you keep your permissions and your ownerships. And you don't lose those. If you were doing a backup on an entire, if you were on a server and you're backing up the home directory for all your users, and you just copied it across, when you copied it back after a system failure, those users are not going to own their own files anymore. And that's also the same with system processes. Some processes are going to own certain directories and certain files. And if you restore that, they're no longer going to have that layout, and it will cause you basically to have a system that doesn't function, because it does need that information.
Okay, thanks.
Yeah, on Unix systems, like if I used it the other day, and you have to be really careful with tar, because if you don't put in the right flag in certain circumstances, you try to restore your machine, and it won't work anymore. It happened with my laptop. I spent like 3 days reloading it because I missed one flag on tar.
What do you generally use for that? Use the tar program?
Mm-hmm. Yeah, in fact, I do it over the network too. Pipe it to SSH like he was talking about, the standard output, and it works really well.
Pipe it directly through a secure connection to another Linux box or Unix box. Really nice. Anything else? Any questions on how to do something? Okay, well, if you have any questions, just give a holler, and we'll see what I can do to get your questions answered. We'll be starting next. Are we doing, where's Mike?
Hey,
Are we going to be doing one next month?
next month we'll probably forfeit the meetings next month, just because it's really close to Christmas and most people are going to be out of town. So probably next one will probably be the 3rd weekend of January. We're going to probably do the next meeting.
Then we'll resume. We'll get quite a bit more complicated in the next one. We'll start working on some some more of the advanced commands, and a little bit into starting the script, basically creating very simplistic scripts.
I just want to suggest maybe not a class session next month, maybe an install test. If anyone's interested, I don't know. Or is this place not available at that time?
It may not be.
Let me jump over real quick here. Well, because the 3rd Saturday is actually on the 19th. It's not
Yeah.
that bad.
Or about the week before the fall, maybe Sunday the 3rd.
Should bring you into.
Should bring you a console.
Only at this company.
Oh, does he have a sub key?
There's
He's also running Genome too. I don't know if that's specific to your Windows manager.
Maybe Control Shift F1. I
I
know
use Fedora and Red Hat has always been a control alt.
Yeah.
Even in
it's
Genome?
not OpenT, is it?
I don't need
Yeah, it's just pulling up the,
It's
remap them.
Yeah, this is my.
Oh, is that your control?
yeah, if they've been remapped, then it may not work.
There it goes. Oh, you remapped the piece. So now you're in your console.
So this one is.
Yeah, so when you, that's gonna be your shift.
Another thing will be the up arrow key to repeat your last command. A lot of times, you'll have lots of commands that you type in, and just pushing the up arrow will go through all your commands, even your typos. So you can go through it. If you're doing a lot of work on the console and you don't want to type these things out like this again, just up arrow. Now,
Type in the history command too.
history.
Yeah,
That's a new one to me.
just type history.